Hello and welcome to a demonstration of circular motion and the acceleration involved. Here we will use the tool PHUN, and to make a circular motion in PHUN is pretty simple. What we need to have some mass which rotates and be attached in a trajectory to this one, but first we start with the mass. We take here this object. This is our rotating mass, and then we have a look first on this property. I want to make an idealized mass, so I give it actually a large high density, so it's really heavy, this guy, something like gold. Then we add a small string to it. Here I use this tool here and make the brush size nice and small. So this one should be idealized, so it should be actually massless. And I'll make just a straight line, more or less straight line. So these are now connected, and then I add a hinge. So depending on how your setting is for the gravity, so what now here is the air has no resistance and the gravity is also off. So if I run now this simulation, then nothing happens. If I switch gravity on, then this one actually is an unstable point, and we'll come to that later. And we see there's also some losses, it doesn't come back into itself, but okay. If we switch off gravity, then this whole thing starts to rotate. But we can also stop this one, and we can tell PHUN that this hinge actually is not only a hinge, but it is more than that. It is a motor, and it rotates with a certain velocity, 15 rotations per minute. So now this one rotates with a constant velocity, and bring it here a bit more into the center. Okay, now we attach here a small marker, make it a bit smaller. The tracer, how is it called? So the tracer lasts for a long time, and the size is small, and clear trail, and then let's run this. So what we see is we get a nice circular motion with this motor, and this is what we call a two-dimensional circular motion. And we know that also the speed is constant for this object, the velocity isn't, and therefore, as the velocity isn't constant, there must be some acceleration occurring on this object. The acceleration, which changes the velocity, not the speed but the direction of the velocity, is called the centripedal acceleration. So it is always accelerated towards the center on its motion, and we can demonstrate this in this with PHUN very easily by cutting the line, line of the circular of the mass connecting the motor. And if we cut it, we will see that the motion is then not accelerated anymore. And if it's not accelerated anymore, then the velocity doesn't change. And in 2D, this is a straight line. It's the same also in 3D. And let's give it a try. So what we do is we stop the motion here at this point, or let's say continue. So, and now I cut the string, and I use here this cutting tool, just cut through this edge, and then let's see what happens. You see, at the moment where we did cut it, the velocity doesn't change anymore. Therefore, this object moves at a constant, with a constant velocity along a straight line, and this trajectory is tangent to the circular trajectory. So it's a tangent. It is to this circle, and it moves then without any further acceleration along this line. This only works as long as we have gravity switched off. If you have gravity switched on, we have a more interesting motion. We have both. We have a constant velocity once we cut it off, plus we get a projectile motion, and that is a parabola, and that is something you might want to try yourself. I suggest that you play with PHUN and try to redo this example and maybe change some parameters. It is actually interesting to see what happens if this object is not like very heavy. The object of the mass is not very heavy, but if it's about the same mass as the string attached to it, so then you will get some interesting motion of the object plus the string or this connector to the motor. Okay, bye bye.